problem.
Okay.
You can talk.
Yeah.
And
I just realized that we've been muted online, so apologies for that, but we're still starting out, so
you were muted?
Yes, I was
okay,
muted.
So they can hear now.
They can hear now.
That's good.
Okay.
That was an easy fix.
Yes, sorry about that. I had too many buttons to press initially, so we failed big time on that one. We haven't covered too much yet, so you haven't missed much. So hopefully from now on, the online participants will also be able to follow properly. As I said, the end users that we have in mind range from people who build all kinds of implementations for research data infrastructure, portals, data centers, and so on, and then also service providers, and potentially then people who are interested in or providing services around semantic artifacts and how to transform between them. The practical outcomes that we set out to achieve are listed there, but I'm going to modify them slightly on the next slide. The ones that are in this lovely RDA green are the ones that we think can still be achieved within the remaining time for the working group to continue. But there are two in RDA brown on the screen that we don't think will be achievable within the next 6 months, although the initial work to define these things have already been done. And that is a set of recommendations and best practices for implementation of brokering registries. And the other one is then testing these implementations or the recommendations in the context of real life applications. I think those will be a bridge too far. But we're aiming to look at defining the concepts and then moving towards establishing the vocabularies, the metadata schema, and a definition of how these services should be built and what kind of functions they should be supporting. Okay, some examples. There's one missing at the top, which is quite surprising and a little bit of a problem, but we'll go forward nevertheless. So we're identifying, as we said, 3 types of transformations that we call mediations in the working group. Those are semantic transformations, schematic transformations of 2 types, and then syntactic transformations. And it's a pity that that top example doesn't show there, but it's similar to the top example on the right-hand side of your screen. So that semantic transformation takes an object that we can express as A and transforms it into something that is quite different that we can call B. So there's no real correspondence anymore between the original object and the target object. The schematic transformations are of 2 kinds. The best example to think about there is to say I've got some kind of data or metadata in a schema that's based on XML. And without changing anything else, I'm transforming it into JSON. So it's still recognizably exactly the same thing, but it's just shown a little bit differently to the end user. There's a change in the encoding schema, if you will, of that object. The second type of schematic transformation takes one schema and transforms it to another. And you'll notice that the arrow between those two doesn't go in both directions because very often that thing is not reversible. So a very good example to think about there is where in one schema you might have different elements for things like name and surname and address. And in another schema, those are concatenated into one element. So unless you know a little bit more about how those things were concatenated and how they separated, you can't go back to the original from there. So that's the second type of schematic transformation. And then the syntactic transformation doesn't change the payload of what we're getting at all, but the wrapper in which we're sending it is different. So an example of that might be that I can ask for a Dublin core metadata record from an OAI PMH endpoint, or I can ask for that exact same metadata record in Dublin core encoded in XML from a CSW endpoint. So the wrapper and the syntax that I use to access it is different, but the end result is exactly the same. So those are the sort of basic types that we are talking about. The second column on the right-hand side conceives of the idea that it's possible to go from one place to another with some intermediary step. So I can go from A to B, and from B, I can go to C. So by implication, with having that intermediary step, I can go from A to C as well. So it's a little bit of the idea, almost like a map, if you can think about it, with the road going from Copenhagen to Gothenburg, via some towns here in Sweden in the south. So that's the same kind of idea. All right, there are also more complicated examples. Not sure why this is not always registering. So we are also facing situations where there might be a transformation where more than one input is sort of concatenated into a final result. So this is a much more complex basic type to say we take information from A and B, and then we somehow combine it into an output that we call E. So that's how far we got in terms of thinking about these basic transformation types. And then on the bottom right of the screen, is a very important extension, because all of the things that we've looked at up till now are what we call mediations. It's a transformation from one thing to another. But the brokering involves understanding how to navigate in a network or a graph that has all of the different relations between these things. Analogous to, for instance, finding a shortest path on a map between A and B. Now, to be able to do that, what it in essence means is that we create something called a minimum spanning tree in graph theory terms. That's basically the overlay of all the shortest paths between the different components. And this is conceptually quite interesting, because it means if we have the basic information about all available transformations, we can go and determine what the minimum amount of transformations are that we need to get from every one metadata schema to any other one, for argument's sake, and which of the ones that are there might be redundant because they may be lossy or not reversible, and so on and so forth. So conceptually is quite an interesting extension in future in terms of the brokering capabilities that exist within such a graph. There are some definitions that we won't have time to go through. The most important definition there is something that we call a signature, which is an unambiguous reference to the collection of inputs and outputs that are associated with such a mediation process. Because we cannot index and find these things if we can't unambiguously characterize them in terms of their inputs and outputs. So that's a very important part of the work that needs to be done. Okay, we've thought about things like a typology, the level of formality, and we're thinking that something like technology readiness levels that came into being maybe after the working group started initially would be an interesting part of such an evaluation. There are typologies in terms of the transformation type, and we can make time, I think, in the next few months to have workshops on discussing these typologies in detail, because they determine the vocabularies that we want to attach to metadata for describing all of the transformation processes. And then we've also developed some ideas on these transformation types in more detail. You can read it later on, I suppose, because again, we won't have time to go into it in detail. But we've identified all these subtypes of transformations together with descriptions, and whether they are reversible or not, and whether they should be executed synchronously or asynchronously, because that's also something that's quite important to understand if you're planning to use chain services in some kind of a process. Okay, so the kind of things that we need to sort out if we want to implement anything is the metadata that's associated with these descriptions of mediation services and components. As I said, whether they're synchronous and asynchronous, the kind of information that we want to collect if we want to consider aspects or implementations where there's any kind of process chaining or a workflow definition and what those properties might be. Now, in principle, they could be anything. It could be things like costs or how long it takes to execute and so on and so forth. And the more metrics we have, the simpler it becomes to broker eventually by sort of addressing a subset of the graph or extracting a subset of the graph that meets the end user's requirements and expectations. Okay, and as we said, some of these are reversible or not. And certainly, if a transformation is lossy, like for instance, a compression of an image or a video, it cannot be reversed. And conceptually, we haven't yet come to the conclusion whether it's only in the case of information loss where these things are not reversible. I think not. I think the vast majority of those cases will involve a loss of information. But there are some cases, for instance, this concatenation case, where if you don't have extra information, you can't reverse the process, but no information was really lost. So we still need to figure that out a little bit. The signatures are the most important part really to sort out from a technical perspective, because thinking about metadata, what must be in the vocabularies and so on, straightforward. But there's some technical decisions to take about how to specify these signatures in such a way that they work properly. And that's also work that hopefully within the FAIR Core for EOS project, we can think a little bit about and come up with good recommendations. So I'm not going to go to it in detail here, but just note that we have this, let's say, decision to make about what the best practices might be in terms of defining signatures. Now, there's a very important report in the life of this working group called the CEMAF report. This happened while everybody came to a halt during or just before COVID and during COVID, so it was a nice filler in a way. But the CEMAF report looked at semantic mappings and how to define a framework for semantic mapping. And in essence, what was written up in the CEMAF report is to some extent a subset or a specialization of what we're talking about in the brokering framework, because we are covering not only semantic mappings, but also other technical mappings between resources. So the CEMAF report serves as a very valuable input and confirmation of the kind of conceptual model that we need to develop, but we need to go and modify it amongst other things with this proper description of signatures. And we've had some examples or proposals already in the working group to date on how we are going to define the signature, so we can potentially create a composite index type unambiguous references by hashing up the signatures of all the input and output resources that the process can handle, or we can refer to it with some kind of a linked open data graph-like structure that basically contains the same information but has pros and cons compared to just a hash index, or we can just put it into properties that we record for each of these instances of a brokering or mediation step. So these things we hope to develop in a bit more detail later on. On the right-hand side, you'll see that if we have a resolved artifact, we need to be able to find that artifact on the basis of both an input and an output signature. And the candidates for it combine aspects of maybe a MIME type or an extended MIME type, some kind of reference in a URI to a fragment or a bookmark of a thing in some cases. And there's newly developed specifications for something called a profiled representation, which may also be useful. Now, Tommy will speak a little bit more about that, because in the FAIR Core for EOS project, there is the possibility of, well, there's not the possibility, there's a task to develop a data type registry. And that data type registry for us, I think, will be a perfect input and vehicle to help to define these signatures unambiguously. So we're going to modify the CEMAF conceptual model, or we have modified it, to be able to accommodate a broader scope of transformations, technical transformations. So we're adding signatures to the characterization of a mediation step or a mediation process on the left-hand side of the screen, you can see that. And then on the right-hand side of the screen, in addition, or making the properties envisaged in the SEMAF model more specific, involves saying that we have some configuration or parameters that is associated with each process that we need to record somewhere. And then all of these metrics that we wish to record, like execution time or cost or any other kind of thing that's useful for brokering, needs to be added as specific properties that is a property of the relation between the source and the target, or the object and the subject in term as expressed in SEMAF. So that's the broad scope of, sorry, someone wants to take a photograph.
Thanks.
So we're going back quickly. All right, so again, very little time today, but the other kinds of things that we've looked at is to develop a metadata schema. It is based on DataCite in terms of content, so that if we want to use DataCite, it's easy to register a DOI. But in terms of encoding, it needn't use DataCite's schema. It may use DCAT or anything else that's convenient. So we're still thinking a little bit about that. But we've defined a whole bunch of metadata details based on that DataCite schema. The ones that are highlighted on the screen are new. In other words, they extend the DataCite schema with properties that we need to know when we are talking about transformation process or service. So those are all indicated there. And then very important, at the full right-hand side of the screen, there is a vocabulary. So those elements that we are listing there with the vocabulary means that the working group has to come up with some proposal as to what vocabulary will be used to describe that property in the metadata schema. And here is a list of all the vocabularies. The contrast is not very good in the presentation, but the ones that are highlighted in light blue are new vocabularies that don't exist anywhere else, that the working group has to think about and say, okay, here is a proposal and recommendations for what should be in that vocabulary. We've also thought, finally, about the implementation details. If such a registry would be created, what kind of services should it make available and what do the payloads look like? So here's a summary on the screen of the type of typically REST interface calls that you would like in such an API to a registry together with a payload. And then, as I said, what this working group in its lifetime won't have time for consideration, but the work is there, is a fairly comprehensive list of recommendations and guidelines and best practices for such a registry. And that's maybe something that we can take forward in Fair Impact to say, already thought a little bit of what the good characteristics of such a registry should be, stratified by what must be there, what will be good to have there, and what will be like a cherry on top if it's there. So all of that is also available. Okay, so with 30 seconds to spare, over to Tommy. So Tommy, the floor is yours together with a remote control.
Thanks. Let's see what happens. Yeah. All right, so I'm Tommy Suominen from CSC. I'm the coordinator for the Faircore for EOS project. This is the location, so I'm not blocking the screen. I will talk about not the project so much, but two services in particular which are of relevance for this working group. But just to give you a short introduction, Faircore for EOS started last summer. It's a research and innovation action, and that means that we're doing concrete development work, really working on implementation. I will just go through the context very quickly. You have maybe some idea of what EOSC is. It developed a strategic research and innovation agenda, which identified those points for the EOS infrastructure that needs the most development currently, and their main aims are the minimum viable EOSC and a web of fair data. Those are the main aims of EOSC in the midterm. Now, the challenges that they identified in the SRIA relate to identifiers, metadata and ontologies, interoperability and research software. So then those are the topics that our project addresses. And we address those topics by developing 9 new EOSC core components: the EOSC Research Discovery Graph by OpenAir, the EOSC PID Graph by DataCite, the EOSC Metadata Schema and Crossword Registry is being created by CSC. GWDG works on the data type registry, and then also GWDG and DataCite, they work on the PID meta resolver. The EOSC compliance assessment, EOSC PID policy compliance assessment toolkit is being worked on by DUNS. And SURF is working on the EOSC research activity identifier service together and in concert with ARDC. And then Software Heritage / INRIA is working on the EOSC research software APIs and connectors and the Software Heritage Mirror. And we will now pick from these 9 tools. We will focus on the data type registry and the metadata schema and crosswalk registry. There's a pointer probably here, but yeah. So this one and this one. So first, I'm showing slides from my colleagues. So some of them I know better, some of them less well. But this is the data type registry. What is it? It's a mechanism or service to promote the interoperability of data, to help parse and understand and reuse data created by others. So it allows the data creators to record implicit assumptions for interoperability among data sources, and it provides a hierarchical model of basic data type descriptions. It allows users to register data types depending on the community needs, so community-specific data types. They can be as simple or as complex as necessary. They have relationships between each other in the hierarchical structure. Each type will be provided with a PID, which is a handle, and a common set of metadata. And then there will be a DTR toolkit to actually operationalize this service for the users. How we foresee the interaction between the data type registry and the metadata schema and crosswalk registry is, for example, the MSCR will request a list of data types, and then the DTR returns it by API. We refine searches, and we get a refined list of data types. We can send a request to create a new data type when we are creating schemas in the metadata schema and crosswalk registry. And the DTR will serve the MSCR in this regard. Then for the metadata schema and crosswalk registry, what we're creating is essentially a metadata interoperability service. So this slide I will stay on for a while. So our requirements are to create a registry to support the publishing, discovery, and access of metadata schemas and crosswalks. The schemas and crosswalks can be either hosted there in the registry itself, which means that the PIDs point to the schemas there in the registry, or they can be registered when they're already hosted elsewhere, so that you basically let the registry know that this schema exists and the PIDs point to the source that is actually hosting it. We will provide a mechanism to operationalize the metadata conversions by combining crosswalks. So that means that we can chain the crosswalks and go from A to B to C, as Erwin was just talking. Then we will support minting the PIDs and the metadata descriptions for the metadata schemas, the crosswalks, and the data types, thus making also those resources more fair. So the PIDs for the crosswalk, the fairness and of those as items of data on their own right. Then we will develop the mechanism and guidelines for community or individual users to register metadata schemas and create crosswalks. So this also means that if we have a community endorsed crosswalk there, then individual researchers can come and version that crosswalk, tailor it for their own use cases in their own study. Then we will create a graphical user interface where you can visually create these crosswalks. And then it's designed to facilitate conversions between metadata schemas and integrate the DTR in the metadata schema registry using the DTR API, as I showed in the DTR slide. This means that typing metadata schema elements and attributes and using those registered data types and data type converters for format conversion. So the data type registry also includes the descriptions of how you can actually go from a unit, from a Celsius to Fahrenheit between different data types. So the conversion rules are expressed as equations, and you can actually then translate data between units. Yeah.
Are these actually functions? Or
yeah.
So you can actually
operationalize
the mapping. So it's not just the mapping from a field to another field, but you can also have a function and have a set of functions that does that.
Yeah. Yes.
So are you thinking also of calling external functions like web services?
For the conversion?
Yeah.
I don't think we have thought that far yet.
Okay.
I'll show the timeline, which you of course know as well, but we have just finished the first specifications and we're working on this first implementation now. First sprint has just started this week on the implementation. For the, kind of referring to what Wim was talking right now, of which types of mediation, according to the mediation typology we're working with. And we are working here on the schematic transformations. So the object model change would be when you map an information model to another information model. Includes also the cardinality. When you have one attribute here, 3 here, you can go maybe from 3 to 1 by combining them, but 1 to 3 is a bit difficult because then you would need the rules to chop it up and it might not be even feasible. But then at the same time, and I will show this in a consequent slide, but the platform we adopt allows actually for annotation with concepts of schema elements. So this means that we can have 2 schemas as well with annotations from different vocabularies, which actually also leads to the fact that we might need to map the vocabularies to each other as well, which will then again feed into the possibility that we can actually infer the crosswalks if we have the elements of the schemas annotated with concepts, and we have a linking between those 2 concept vocabularies. So the MSCR requirements, there's a lot of text. Metadata schema should be supported at different levels of complexity, depending on the contributions, requiring or upgrading those existing contributions. So this is the versioning that I have been talking about, with direct links to machine-readable schema with explicit semantics such as XML or RDF. Crosswalks and semantic mappings should be supported at different levels of complexity, depending on those community contributions. So we might be getting things in CSV or some simple format, which we have to then actually refine to an internal information structure that is more advanced, such as OWL. Now, the crosswalks and mappings, we will talk about in RDF, JSON linked data, and SSSOM as the preferred approaches. Registered we foresee to be seeded initially from the RDA metadata schema registry content, and the metadata schema and crosswalks available from other ES components for bootstrapping our services, such as the EU.Central B2Share. But we have also quite a few case studies, which I have now excluded from the presentation in the interest of time, that we use to actually showcase these tools and ensure that they work in different real research contexts. Now, the MSCR will be now based on a service called the Finnish Interoperability Platform, and it's actually closed. Helps if I open it. This platform is open source. The source code is on GitHub, and it is intensively maintained and developed by the Digital and Population Data Services Agency in Finland. It comes with 5 pre-existing modules. The group right management that allows access control for specific groups and the integration of an external AI. It has management of code lists, which would be something like the language codes and the country codes and different application-specific code lists. Terminologies, ontologies, vocabularies, data vocabularies, and a commenting tool. The data vocabularies is essentially the information modeling. It comes with a shared UI components and a design language, which we are able to reuse. And the data layer is a mixture of graph database and a relational database. And then it comes also with integrated Elasticsearch OpenSearch. And by building our services on this well-maintained existing platform, we get resource efficiency in our project work, in the sense that the development speed is expected to be quite good, because we are able to reuse such a wealth of existing solution infrastructure. So essentially, we will take everything that the platform currently offers and extend based on that. So what do we extend? We will be customizing and extending this interoperability platform, create an MSCR theme, and refine the group admin functionality. We will create new domain objects for schemas and crosswalks. And then it utilizes currently cool URIs to point to the resources, and we will convert that into utilize actual PIDs. And then on top of those tools, our applications that I showed that it has, the 5, we will add a new application, which is a crosswalking application. So this is dedicated for creating and reusing the mappings, an internal model for describing the crosswalks, and custom data types from the DTR for integration. Then some of the things are still a bit open, such as the tools for facilitating the operationalization of the crosswalk. So how do you actually make them calculate? And I think Gavin, for example, here has some experience in running a very large scale crosswalks in the calculation sense, that when you're actually doing the transformations. So this we will need to see if we offer this as a container that you can deploy yourself, or because the issue is also that if you have very large data sets and you offer this as a service, it will become an expensive service to maintain with a lot of calculation going through. So we foresee a lot of use for this. Now, the transformations also refer to the formats. So the XML schema descriptions, JSON schema descriptions, CSV description, RDF. So all of these things we will need to deal with as inputs, and we will also need to be able to transfer between these different schema descriptions, because some of the things will be hosted that users will want to register will be in a colorful array of these. And we will need to also be able to map between the different code lists, for example. So if we have data types utilizing one code list and a data type utilizing a second one, we'll actually have to crosswalk those code lists as well. How am I doing for time?
5 minutes.
Okay. So then I will stay here for a little bit. This is the current implementation of the platform. So we have the vocabularies, which I mentioned as one of the applications that exists. This is an existing part of it. And then we have the code lists. And then we have 2 types of information models. So we have essentially the core classes in OWL. And then we have, when you have a concrete application of the core class, utilizing the core classes, then this is in Shackle. So we have classes, attributes, and associations. And then you have to have a concrete class here, which is then utilizing the code list. So this is the abstract classes, essentially, which are the base from which you extend these concrete application profiles. Then these are then, well, the classes themselves, and these are the instantiations within the system. Then we add on to this are below here you can see the conceptual models of the incoming schemas and data. So XMLs will have elements and attributes. JSON will have JSON schema description has objects and properties. CSV has just columns. So we will have to deal with translating all of these into the more complex structures. So we need to have that internally so that we can have PIDs and pointers and create the crosswalking capabilities. And then a bit of we have still a lot of issues to resolve on this. We have just gotten started, but in Wim's slides from the RDA 17, there was this comment, which he actually just made now as well, that not all mediations are reversible and some mediations are non-commutative. And earlier on Monday, Dan was stating here that essentially information loss due to aggregation, and aggregation can be lossy and non-reversible. The metadata may actually, or the aggregation of metadata may harm data discovery, as the fitness for purpose may be more difficult for the user to evaluate due to the information loss. So if you have an aggregated catalog into which you're mapping a lot of disciplinary things, you will lose disciplinary detail. But if for the data discovery, you need that disciplinary detail to actually understand whether this is useful for you, then this is an issue that is of quite vital importance. The SSOM paper says that mappings are directional, so they are defined in one direction from subject to object, and whether a mapping can be interpreted back from object to subject is purely defined by the semantics of the predicate. So an equivalent class is a symmetric relationship, but not everything is. And how this goes, yeah.
Just before you go on, to clarify, you describe how you need to map schemas into different languages and domain formats into the internal one, okay? And that's clear. So when I access this tool, I can read and interpret the schemas and the crosswalks using a common, say, understandable language. The problem that I haven't seen is the other way around. So my schema is in XML, right? So, and I would like to use a crosswalk that I can access from your system.
Mm-hmm.
How is this crosswalk translated into something that I can use in my XML world? Because the mapping is not going to happen on your side. The mapping has to happen on my side. So if I have XML for format George, right, and I come to your tool and I find so many mappings from George to Anna, whatever, and I would like to apply them in my own domain. So how can I translate your crosswalks into usable crosswalks in my universe?
Well, the idea is, well, I mean, when you register your George, XML George, we will have to upgrade it so that we can actually create the crosswalk so that we have PIDs for all the objects that you are crosswalking to. And then that crosswalk itself will be exportable. You can take it to go as from McDonald's so that you can operationalize it in your own system. But we have realized that we have issues in the fact that the crosswalk is in, I don't know what would be the term, but like on a more expressive language. And then is that crosswalk translatable downwards into a language which has less expressive capacity? So these are things that we have to really think about, that if we deploy it to you in an advanced format, that might not be usable for you. And then the other issue is if you register an XSD schema with us and we upgrade it, and then from that upgraded version you export it, will it be identical to the one that you registered?
It will not be.
No.
It will not be.
Yeah, highly likely.
Maybe what you should do is also think of providing together with the tool that is of course useful, also pieces or libraries that others can use to embed in different domains or different jobs. So this language that you define to be much more expressive, maybe can also come with the libraries that I could reuse to apply it in my domain. There are issues anyway, because for example, we apply this kind of mappings in OpenAir in a highly performant environment where some code cannot be reused. So if you do it on a Spark cluster, you cannot use XSLT, right? So you have to adapt it to code again using Python, using all sorts of solutions. So there are intrinsic issues that could be solved and should be solved out of the tool. Anyway, so it would be interesting also to see the boundaries of this tool, not just because otherwise I'm throwing things in and I will never be able to use them properly.
Can I just ask that we maybe continue because we run out of time? No, but I think it's good to get this feedback, but a detailed discussion needed potentially after. Yeah. Okay, cool.
I put here the example. There is I found on the web crosswalk from Inspire to DCAT to EML. And here is an example that the Inspire terms here, for example, here gets translated to map to DCAT, DCAT to EML. But then we had instances here in this tripartite crosswalk where the Inspire doesn't have any match in DCAT, and then actually it skipped DCAT and went directly to EML. So this is an example of a crosswalk that is kind of between three different schemas, but integrates skipping out the schema in the middle when it's not applicable. And this is one example of a lossy conversion or translation or mediation, because it's not possible to get these informations into DCAT, but only into the more advanced EML. So yeah, that was just an example that I wanted to highlight. And just to say that we indeed started this project. We just finished our specifications and we are just in the phase of starting our implementation work. But by November, we will have the first beta release out. So we will try to carry out very intensive software development in the coming 9 months that we have left. And then we will have integration of use cases into the tools, and then it will still take some time for the final versions to be released. But we aim to have something in beta use relatively soon. And with that, these are our partners working together on this project. And if you want to find more about the project, there's a link to a webinar that you can watch. And I think we have questions still, but how about...
I don't have time though, but...
Yeah, so maybe if you don't mind keeping your question for the discussion part, because I'm worried that we might not get around to everything we need to do in time. Thanks, Tommy. Okay, so next up is Anne-Sophie Fink. She's going to talk about fair impact. So again, the floor is yours together with the remote control.
I'll start. Moving forward. Yes, I'll talk from the Fair Impact project, and especially from the work package 6 on interoperability, and more focused even on the task 6.1. Yeah, my name is Anne-Sophie Fink, and I'm leader of work package 6, and I'm standing in for Oscar Kochu, who actually was supposed to do this presentation, but unfortunately couldn't. He's working taskfully together with Esteban Gonzalez. And first of all, actually, I have to thank Lasso Calelecci for putting up slides. She's hiding in the back. Putting up slides for us in a hurry. I have done a bit of adaptation afterwards, so if there's any sort of slide-wise problems there on me. But what we will be showing today is more of an overview of the project, the work package and of the task, and very much in light of sort of giving a handshake to the working group that we would like to feed into to the work they're doing. So first of all, a slide similar to the one that Tommy showed about all the participants, and the University of Madrid, where Esteban and Oscar is from, are hiding up there. So when you get into more discussions, that's those guys to talk to. So a little bit sort of on the project as a whole. Fair Impact wants to expand Fair Solution across Europe. I could say right away that we are indeed very much connected to Fair Core for years. As you can hear, they are developing stuff, as we are kind of more enabling the fair practices. Coming from the core, enabling discovery and interoperability of federated research objects across scientific communities. So that's kind of our work. And as Wim actually mentioned, and it's not very clear, actually mentioned a lot of the slide, but this is very much about taking on communities and hearing about taking their needs and wishes in. And we want to expand the solution in Europe, which is smaller than Congo that we just heard. Yeah, so it shouldn't be a problem. And we are partly following up on the project, which you also might know, that's Fair. 10 million euros. Same sort of time perspective as Fair Core for years, 28 partners. I think that's sort of the outline. And to get a bit more into details, what we want to do is to realize a Fair Core by supporting the implementation on fair enabling practices across scientific communities and research outputs. In a very broad sort of geographical outline and institutional. And again, the word across is kind of very important. We're working with use cases, but definitely want to have use cases in to work across communities. How are we going to go about it? We want to identify current and emerging components for enabling fair, and that's all practices, policies, tools, and technical specification. All of it's beyond it. We want to translate viable solutions, guidelines, and frameworks that have been developed, and again, cross-domain, and take it to other domains. And taking the next step in implementation by defining the support, governance, and coordination. And that's maybe not so much last one for today. This is how the work in Fair Impact is structured. We talk about some sort of kind of pillar work packages on, first of all, the project management, persistent identifiers, metadata and ontology, metrics and guidelines, and of course on the dissemination and exploitations. And then we have sort of the ribbons, the crosswalkers, and that's work package 6 assignment and on interoperability, and the one on work package 2 on engagement and adoption. So where we sort of take off from for work package 6 is indeed this year's interoperability framework. Wim also mentioned it in the beginning, and we talk about legal, we talk about organizational, we talk about semantic and technical, and of course in this case it's on the semantic and technical stuff we are focusing. The overarching objectives: design and promote interoperability mechanism across domain, again, and institution, and foster global alignment of fair frameworks. So sort of huge ambitions. And so the expected impact for for our VP6 is agree on and implement a common set of rules to ensure data and services within IRSC that support interoperability. And again, to condense that, what we will do is that we will collect rule-related outputs, and you can see from the pillar work packages and across the use cases they are working with. We want to promote the use of already existing common technical specification standards, or infrastructures endorsed by the various scientific communities. And again, taking that down or sort of focusing that by map out the common ground for our 4 use cases. Let's call them scientific communities. And again, use cases, very, very important. And again, that is this outreach and sort of taking these perspectives in. We'll foster alignment with existing framework and standard from non-scientific large data sources of interest for research. And I'll stop here, as this is sort of the task that we mostly work with that. Just that you see the European data spaces, I think that's very ambitious that we will sort that out too, but we'll come back to that. For especially again to focus from VP6, the focus today is in the semantic and technical core interoperability across domain, and we want to deliver these guidelines for the use of components for technical and semantic interoperability across domain use cases. And I'm repeating myself, but again, you can see, I think you can sort of see the obvious connection to the work in Fair Core for EASC, and definitely also for the sort of the outline of this working group as Wim outlined. And I think there's too many, a bit too many words on this, but a little bit more details for the 6.1 task. Yeah, we will analyze and demonstrate semantic and technical interoperability. And again, I think that will be said repeatedly. Generate guidelines. Again, we are on the enabling side of things, where Fair Core for EASC is on sort of the development of component side. I think what I would like definitely to stress out is that we will take this into account, and I think again that's maybe that could be of value to the work in the working group. But we will take in this recommendation from the EASC interoperability framework. This is what we sometimes call the laws that we talked about before. On the task force, some news from the task force on semantic interoperability, and there's been some extensions to the interoperability framework from this European interoperability reference architecture. So take that into, and again taking recommendations in from the other work packages, these pillar work packages in Fair Core for EASC. Again, a bit of a sort of interlinkage there, and we have to sort of juggle the different deadlines of output from the work packages. And ongoing and future development by related project, and I maybe should have put that in bold, but again, the sort of the huge best example is the Fair Core project. Will inform these projects about what we've been doing, and especially in this case, I should mention again that we will look into specific research data descriptions mentioned in the EASC framework, interoperability framework, and again, this cross-domain perspective, and then end out with these recommendations. And just to mention that we are very much dependent on use cases, and for these different research institutions will give us sort of domain insights on semantic and technical interoperability, and we will work from that in this task. This is just to show our sort of initial approach, what we have, and some of you might sort of recognize these pictures taken from the interoperability EASC interoperability framework. So we use that for just discussion with our integrated use cases, and also the sort of expert partners involved in the task, and sort of from this had an initial idea about how to set up, how to continue the work, and what the next step will be to set up a questionnaire or survey called based on of course these frameworks and the inputs from our use cases. I should have put also our partner experts. And then this questionnaire, the survey, will go out to all our integrated use cases in fair impact. We would like to move even beyond that for inputs, And again, I think you can see how this could go into both work in Verco for IRSC and in the working group. Yes, this was sort of initial thought, and talking to Wim about how the task 6.1 and Verco, Fair Impact as a whole can contribute and collaborate. So we hope our output could be useful as inputs to this conceptual model that's being developed. And this could be by identifying vocabulary needs, metadata schemas, and specifying service methods and payloads. We could be adding to a more federated and interoperable set of registers of mediation services, components, artifacts, and this was how it was spelled out in the description of the working group. So we hope to do that. Until then, we hope that we can the working group recommendations and design, as presented here, can serve as input for the work in task 1.1 and the work actually in Impact as a whole. So yeah, that was it. Sort of more of maybe an overview and hopefully kind of a handshake to stay in touch with the working group.
Yep.
Yeah.
Thank you. Okay, thanks very much, Sophie. She's saved us a few minutes, which is very valuable, I think, for conversation. So maybe before we start with thinking about what to do next, I'm going to open the floor for questions. There may be questions online. Daniel is tracking that, so if there are any, we'll deal with them shortly. But there was also still an unanswered question for Tommy, and maybe other questions for Tommy or Sophie or myself. So please go ahead.
Yeah, I guess it's more a comment, but on this issue brought up with losing information when you do integration of metadata or commercial metadata. And so we're launching another work group on the biomedical domain. So the work group is called Fair Tracks, and this is a continuation of something that we did in Elixir. And this is exactly doing that kind of integration metadata from different data models. So, but how we approach that problem is that we, instead of sort of trying to fix all of these things, we just include reverse references back to the original metadata. So in case you do a search and you want to do more detailed search, you can take the results and then go back to original ones and do more detail there. And I think that's an approach that might be more practical. It's common.
Yeah, I think that's an interesting one, because it's not so much about the crosswalk, but how you would implement that in a practical sense so that people don't lose the capability of finding rich metadata that is maybe format or domain specific. And I think you're never going to find complete mappings between all kinds of data and metadata formats and schema. So somewhere along the line, you have to defer some work to almost like a workaround, by keeping the original metadata, maybe indexing it text only, or similar kind of approaches. But the point is valid, is that we won't ever have perfect mappings, and we have to supplement the end user's experience in a different way then.
Question on Smeeler University. The quality of the information in the registry, I suppose, would determine, if there are inadequate mappings being defined there,
yes,
then we might lose a lot of information transforming from one side to the other. If everybody contributes to the registry, how do we manage the quality of that of those mappings?
Yes, I think a very good point, because there's two aspects here. The one is a governance aspect that the working group is not talking about, and that we should maybe put on the list for future efforts in RDA, amongst others. And the other one is that you might get different opinions about mappings or transformations, and CEMAF actually in their report took note of that problem, is that you may have differing opinions about let's say the predicate that you use to describe the link between two things. And you need to also keep information about assertions and the weight of assertion and whether people disagree about it. So it becomes very complex, but a very valid point.
If I can also.
Yes, so maybe quickly respond.
To the governance aspect, one thing that we have considered for the service that I presented is that we would have community endorsed crosswalks. So where the community really sits down and discusses the crosswalks, that they're not just ad hoc and done on a fly, but they are jointly agreed upon by the community that this is the best possible translation we can have. And then you can have versioning of those crosswalks for specific cases so that they're fit for purpose. And then the other aspect is that we try to identify these central schemas that you crosswalk to in such a way that they're also carefully selected, that they're as expressive as possible and cut out as little detail from that discipline as possible. But when you have disciplinary kind of central schemas, then that allows you to capsulate more of the disciplinary detail than if you be crosswalking to something very generic. But then that's a very different use case in the sense that if you want to have a omnivorous platform that eats whatever, and it takes everything from all the different fields, it is serving a different use case from a disciplinary repository that can be more specific in its schemas on what it expresses. And there's also two ways to design that. You can have a very generic disciplinary that covers only the joint properties, or you can have as expressive as possible that covers all the different variants and possibilities as optional things. So there's different ways to address it.
And then one comment, I mean, in other situations, we talk about programming languages and the likes. There's typically, you can have test suites and do model checkers and the likes. Could that be a solution here as well to ensure that the projections that you make will live up to a certain quality, well-formedness, and all the likes?
Yeah, entirely possible. I mean, we have also just
It will be crucial to maintain the quality.
Yes.
we have been even at some point in the beginning discussing what kind of metrics can we develop for, like, this is a 75% fit, a goodness of fit or something, to express how what quality of a
in the interests of equity, I would maybe say that I think there are two more comments on the same topic from Alexandra and Paulo, and then there's two gentlemen in the audience that have questions. You're in the queue, and then we still have to give a chance for people online. So Alexandra, I think you were first, maybe with an additional comment on this topic.
So I came late, so I don't know what has been covered, but so for example, we do capture metadata about the mappings, and a big distinction is this an automatic mapping made by a machine or a person, and where does that person belong to organization at the time when the mapping happened?
Yes.
Because they can move, but that's a way to capture the organization they work at, and that gives some trust. We also we have governance in whatever we do. We have governance, so somebody looks after if we get submissions of mappings, we make sure that they make sense. And another part of metadata that could be captured is the certainty, how certain it is, how certain you are when you are making the mapping that this aligns to that. And the last one is using, I think I've said it before, that using the iAdapt framework, for example, for observable properties, generally using a framework can help you automatically create mappings when you discuss the same thing. So observable properties can be described in a very structured way like that. And if you use that across domains that describe a certain thing, then the mappings can be pretty automatic.
Yes. Okay, cool. So I think some of those concerns are also registered in the CEMAF report. Things like the assertion, the provenance, who says this, a reference to where it comes from, and the extent to which it's supported by others. But I think some of the comments I mean, the work that you're doing in the ocean science world on those vocabularies, I think should be made available to the FAIR Corps for EOSC work package. And I'll take care of that because I have a foot sort of on both sides. So there are some thinking about governance and unambiguous identification and mappings in there that will already be useful. Paolo?
Yeah, just to point out that I think the whole discussion about losing information, loss of information in general, is a little bit out of context, I think, with respect to the tool that you're defining. So it's intended. So if you lose information, it's because that's what you want to do. Otherwise, you define your mapping in a better way. You can find techniques, you can point back to the original record, you can include the blob of the original record as text in a field, but these are techniques and the way you use the tools.
Yes, I agree.
And maybe, I'm not sure this would be useful, but it could be. The problem I see is that if I'm visiting your tool and I find 3 mappings that match my expectations, how do I pick between these 3 mappings?
Okay, so I think that's the brokering part.
Quantifying loss of information, I think, is very difficult in general. So I'm not sure how this could be done if using yet another ontology that describes something, or if using likes and dislikes from user. I don't have a clue.
Yeah. No, I agree. So I think that the properties that we envisage, at least from the working group's perspective, takes into account that the loss of information is not something that we want to fix. We want to record the fact that there is loss of information and potentially how much, so that the usability becomes improved. I'm going to allow these 2 more comments from Tommy and from you, and then we need to move to the other guys that are in the queue. Go ahead, Tommy.
So I basically want to answer to Alexandra a little bit that that's why we feel that the management of the provenance of the crosswalks is very important. Because you have also the cases where the schema that you just created the mapping to has changed. So then you have to have the schema versioning and the crosswalk versioning to manage the provenance and understand the reliability that your crosswalk actually maps from the most recent version of the schema that is being utilized on one side and another side. And that it has to be also the crosswalks that need to be maintained and flagged if the underlying schemas have changed that they have been made on top of. And that's why they need PIDs, the schemas and the crosswalks and mappings, so that we can point to the provenance.
Yeah, we do capture the versioning of everything that we do in NBS.
Okay. Last comment on this thread.
Sorry, yeah. Well, it's actually a bit changing question, but I'm a bit concerned about the approach of having everything based on the metadata, because you assume that the data that's actually going in there is following the metadata exactly, and that the validation is fully true. And in terms of, especially when for data scientists trying to broker something, and the code data is typically very messy, right? And you have to have lots of validation stuff in order to get to that point where you actually can do that kind of metadata validation. And well, in the same project where we're trying to do a completely other approach, starting from, we're going down to the data and trying to even though you're following a metadata schema, the sort of crosswalks are done on the data level, where you can go in and sort of fix any things as they appear. Yeah.
So maybe just on that point, that's why we think that these signatures are so important. You have to be able to specify the input criteria down to the level where you can, in a machine actionable way, execute a test with a certainty that it will not fail. So if you talk about data as an input, that data has to follow the specifications of that type, a MIME type plus refinements, to the point where you can guarantee that it is exactly what the service or application expects, because otherwise there's no guarantee that it will work. So this is one of the challenges. If you have heterogeneous data that's just in a spreadsheet, then there will be conversion processes registered for spreadsheets that says take a spreadsheet and make it into CSV, but it doesn't care about the content. But if you have a spreadsheet that says this is a budget expressed in the in the way that the university system in the Netherlands wants you to record your budget in a spreadsheet. That's very different. And that's why the signature is so important. Very last comment.
Very last comment. I think here's a point. Having experience in doing this kind of mapping, so
Yes.
and I was wondering if we because the approach you're proposing is perfect, right? So in a way it's rectangular or square, so it's perfect. While data science is not completely.
Oh, sure.
So I was wondering if another pragmatic approach could be, or possibly, to have this tool as a way to access a number of useful libraries that I can reuse in my context to define the mappings that I would otherwise have to re-implement on my own. So maybe we could release a little this
Tension.
strong typing and structure that it requires a lot of work to onboard an XML, to onboard a crosswalk, define the data types, expecting that everything around it spins in the proper way. And maybe I imagine I could go there and find, I don't know, the XSLT and the number of functions or Python or Java functions that I need to combine to get what I need, something in between. So
Yes.
I'm not sure.
Yes, very good point, but we'll have to move on. So I think it's implicit in the sense that we're saying that not all of these mediation artifacts are at the same level of formality. Some of them might just be a recipe written on a piece of paper, but then the type is sort of as open as you can get. Sorry, you've been waiting for a long time.
So, yes, in Faircore for EOSC, in the presentation was mentioned that you have pits for everything, right? And my question is, how do you generate these pits? And are these pits also only valid for the project, in the project itself, or also resolvable outside?
Resolvable.
Okay. Yeah, very important.
And currently the platforms we're developing on, it issues cool URIs within quite a fixed namespace. But we feel we could do it in like this for URNs, but we have to see for what else we want to use. And in the project, actually, there has already been development that they can encapsulate DOIs or handles within a URN. Yeah. So the URN actually then takes the payload to the DOI resolver, and that then resolves to the. So there's a like a meta resolver already.
Yeah. A short statement to this. There is also an idea for alternate these ambiguation issues, to take a look about the ORCID database. So that you can find the DOIs, for example, to documents or also to contributions through different kind of resolving.
Yeah, so I think that's true. And in the Faircore for EOSC project, there is work on a PID graph, at least in the Europe context, together with a meta resolver that sort of speaks to that requirement. But I'm going to have to say, let's discuss that maybe offline, because you've been waiting the longest. So please go ahead.
So tying back to that discussion about metadata, the MIME types and the file format specifications are usually kind of PDF documents, very long, very specific. Most of them are containing or defining a lot of elements that could be more specifically defined by implementers. So, I mean, if you have an instrument producing a type of data, it will contain a lot of metadata or structural information that describe the more kind of the bulk of the data that's in there. And sometimes the manufacturer will have their kind of profile of it, which is another PDF or a website. And it would be nice to have some sort of, I mean, you mentioned a type registry, and as far as I understood it, it's kind of metadata schemas. And I mean, metadata, or that it said so on the slide.
Yes.
So maybe it's meant to be more.
It can be much wider. So in the Faircore for EOSC project, that data type registry is needed for the metadata crosswalks registry, but its intention is to provide all kinds of other data type registration use cases. So it's not limited to metadata crosswalks.
So I mean, a proposal then is that it would be nice to model some sort of partner file that you can have with your data file that kind of describes what kind of content is in that file,
Yes.
and referencing the original specification, which will be a PDF or an ISO specification or something like that.
That's right.
And you can't change that, so we shouldn't reference a UI it's published somewhere else because there's already the
Yes, except that I think in many cases these types are those, let's say, authoritative definitions are not persistent. It's a bit of an issue. Okay, people online have been waiting a long time. Daniel?
No questions.
No questions so far. Okay.
Can I then answer to that?
Yes.
I mean, I didn't want to open that can of worms, but if your data is a 5 terabyte micron electroscope image, you can drill down into it. Then your metadata is descriptive, and then you deal with that very fixed thing. But then what if your metadata is actually structured linked data? Then you could essentially understand the entire data structure and treat it the same way you treat metadata to understand and crosswalk the contents. But then it could be some kind of a binary sensor data, which you can't make heads or tails of unless you have the right equipment to read it in.
Yes.
So because the heterogeneity of the data is very large, then we at least started with the fact of this kind of simple metadata that describes the data set, but not the kind of data structure of the data itself. But if that is well structured, that could be done as well.
So a response to that. So if I'm not sure if you're familiar with the IADOPT concept describing kind of a
Yes.
sample, a read number and saying how it was conceived from a measurement or something like that. So you could have something similar describing a binary blob. I mean, a huge binary blob with a lot of data inside of it. And then you would describe which information is encoded in this file and which file format is it used, so which file format specification, and then you could find, match for tools that can extract a certain piece of information from this type of file. And if you have variations then of like a manufacturer implementing some extra information inside of a file format that is a bit generic, then you could actually see that so there's more information in this file of this binary blob format than in another file.
So maybe that's very valid, but it's sort of outside the scope of the working group in a way, in the sense that we recognize that there's a lot of work to be done to make data more semantically interoperable and for data sets to be published according to certain standards, both in terms of schema and semantics, right? So IADOPT assists with that process. But in the working group, we're only interested in saying there is some kind of service here that will take data or metadata or anything else that conforms to this input specification and transform it to something that looks like this, that has a defined output specification. So it is a parallel and necessary process to improve semantic interoperability of data. That's actually the elephant in the room. When people are talking about FAIR and so on, they tend to focus on metadata. But the big issue in the research world is data interoperability and semantic interoperability of data. That's thankfully outside the scope of this working group. Okay, so maybe then just conclude what we formally set out to do, just to draw your attention to other work that we should look at. This is obscured partly because it's not been published formally yet, but there is an EOS task force on technical interoperability, and they've produced something like 56 recommendations, of which an extract here, maybe 15 or so, are applicable to the working group. So the moment that they are publishable, I will include them into our thinking and maybe go and amend and improve our recommendations or our models or whatever else is involved. There's also some historical use cases from SION, from the Geodata Access Broker, from SEMAF, and from PressQT, which is sort of like a bag translation service that takes bags and prepares them for deposit either to Zenodo or GitHub or Figshare or an OSF compliant repository. That was very interesting for informing our conceptual modeling because it's more of a syntactic and schematic translation and not a semantic one. So those are all of interest potentially.
Yeah, we have used and we still use extensively the GeoDAB
Okay.
broker.
Yes.
In many cases, it works really well.
Yes. So the GeoDAB broker was to some extent a pioneer in this field for brokering, let's say, access between differing metadata standards and to some extent data, developed by Geo. And one of the former co-chairs, Stefano Nativi, over many years was a driving force behind GeoDAB. Okay, there's also some links to other groups, but I would rather skip to what I think the next steps are, with 4 minutes between us and lunch, 3.5 minutes. So I think it's clear that there is a synergy between what FAIR Core for EOSC and FAIR Impact is doing and what the working group has come up with until today. So I think there's no question that we will provide everything we've got, and because fortunately 2 of the co-chairs are involved in these projects, it's possible for us to participate quite actively. So I see the next 6 months as a sort of refinement period with iterations between the working group and what the 2 projects are doing to conclude our thinking about the conceptual model, the vocabularies, what should be in the metadata describing these things in a registry, and what the services are that you would like to access in such a registry. And then I think we must wrap it up. So for those of you that are interested, you must please let me know directly, because we would then very, very gladly include you into workshops that the 2 projects, for instance, are arranging to get community input and feedback, because it doesn't have to be only in Europe. So people from the rest of the world, I think I'm quite happy to say that we invite you to these workshops so that you can contribute your thoughts and your use cases and your experiences to help to refine these. So that's more or less what I have in mind. There are several questions raised here today, things like the governance, amongst others, and maybe more complex use cases, making it more fuzzy, all kinds of things like that, that I think we must package to say that's follow-up work for a next working group in RDA potentially. So I'll also take it upon myself to distill those ideas from the discussion and say, okay, maybe at the next working group, next plenary, we can look for an opportunity to continue the work, but look at other aspects that also have to do with the same topic. So that's what I have in mind, because I think we have this golden opportunity with 2 funded projects that are really complementary to what the working group set out to do, and we should maximize that opportunity. Okay, any last comments or questions before we give you an early start to the queue? All good? So thanks very much for attending. And yes, I hope that we've at least got some enthusiasm and some interest from you for the work that we're doing. Thanks very much.
Definitely. I'm actually
They would like to have collaboration.
initially to be nationally.
Yeah.